If we want to retrieve external information like up-to-date documents or search results and then send them as part of a query to a large language model, there's a technique we can use for that.
Right, that is RAG, or retrieval augmented generation.
Yeah, so say I'm building an internal help chatbot. With RAG, when somebody asks the LLM a question like, what's our latest VPN policy? Well, that is a query, and that query is sent in an input prompt, and that goes to our large language model, our LLM. And RAG can help us out here. It can pull the most recent policy document about our VPN, and it can embed just the relevant paragraphs from that policy document into the input prompt. So the LLM has the relevant information to answer correctly.
Exactly, but a lot of real-world data isn't just text. If that policy includes network diagrams, screenshots, maybe some scanned PDFs, what you really want is multimodal RAG. So the model can understand and retrieve both the images and the text together.
Right, and multimodal doesn't just mean text and images. There could be videos, there could be audio files.
And each of those are going to behave differently. So text is very easy to chunk and index, but images, videos, audio, they need their own pre-processing, their own embeddings, and some way to align them back to the original question.
So let's look at various ways to incorporate multimodal RAG into LLM solutions. Okay, let's draw the classic RAG setup first so we can see where multimodal fits in. So let's start off over here. We have got documents. These are things like, well, VPN policies, but also knowledge base articles, whatever.
Yeah, and step one is going to happen offline. So we're going to take all of those documents and run them through an embedding model. That model is going to turn each chunk of text into a vector, which is essentially a list of numbers that captures the meaning of that chunk.
Right. Then we store those vectors in a database, specifically a vector database. So text documents, they go to the embedding model, they're converted into vectors, and then they are stored in the vector database. That's the offline part.
Right. So now let's look at what happens when the user asks a question. The user types something like, what do we say we were going to ask again?
We're going to say like, what's our latest VPN policy?
That's right. All right. So that is going to be our query, and that is going to go into our input prompt.
Yeah, and then we send that input prompt into a component called a retriever. Now, the retriever uses the same embedding model to turn that question into a vector, and then it looks up the closest vectors in the vector database.
And that vector database is then going to send back the top matching chunks of text, which are deemed the most relevant bits of the original documents.
Yep, and then we bundle those chunks into a context block that sits next to the original query. So now we've got the context from RAG and the query all making up our input prompt.
And that combined prompt is what we send into the large language model. That uses the grounded context to generate an answer.
But so far, these documents are all text.
Right. To make this multimodal, we have a few options, but let's start with the simplest one where we don't really need to change the pipeline very much.
Yeah, we need a good name for this approach.
Let's see. We'll put it here. Textify everything, RAG?
I like it. Yeah, that's nice. Okay, so in this use case, we've got some images. Well, these could be images, they could be screenshots, and they go through a captioning model to become textual captions describing the image. Or if we've got some video or we've got some audio, that can go through a speech to text service to become transcripts.
Exactly. And once they're converted, they're really just more documents, more text. They're going to go through the exact same flow.
Yeah, so this first approach to multimodal RAG is basically convert every modality to text, then just use normal RAG, which is easy enough, but this does come with a catch.
So let's think about a network diagram for that VPN policy. When we run that through a captioning model, we might get something that says, diagram of corporate network with VPN gateway and redundant links. Basically, some text describing roughly what's going on.
Which is technically correct, but if the original diagram had, let's say, a red path that shows the primary connection, and then maybe it has a blue path for failover, and we didn't explicitly know that in the caption, well, that nuance is then lost. Captioning can lose some of that information.
So the Textify everything approach is great for getting basic semantic text, but it loses a lot of the visual context and spatial relationships that can actually be pretty important.
Which leads us to the second approach, which we'll call
Hybrid multimodal RAG.
You are a whiz with these names, Josh. So here we keep text-based retrieval, but we update the model on the other end.
Right, instead of a regular text-only LLM that can just read and write text, we're going to use a multimodal LLM that can take text, images, audio, maybe video as input and reason over them together.
Now on the retrieval side, nothing really dramatic changes. We still got a bunch of documents that we're going to feed in. Plus we've got captions for any images and screenshots. And then we've got transcripts for video and for audio. And all of that is text. All of that, as before, runs through an embedding model. And that embedding model generates a bunch of vectors, which we store in a vector database.
So when the user asks, what is our latest VPN policy? We have that input up here, and then the retriever is going to search over text embeddings, paragraphs, captions, transcripts, and find the most relevant matches.
But the important bit is we also keep pointers back to the original non-text data. So if we retrieve a caption, and that caption came from a diagram, we know exactly which image that caption belongs to.
And when we build the context, we don't just pass the caption into the model, we pass context text plus the actual image into the multimodal large language model alongside the input prompt.
Yes, and now the LLM can read the policy paragraph and look at, let's say, the real network diagram, the red primary path and the blue failover path, while it's generating its answer. So the trade-off, though, is that retrieval is still only as good as the text side. The captions and the transcripts have to be good enough to surface the right image or clip in the first place.
So in hybrid multimodal RAG, the search happens over text, but the LLM still gets to see and reason over the original non-text data when it answers.
So hybrid multimodal RAG sounds pretty good. Why isn't that the end of the story?
Well, it's because we're still betting everything on the text side. If the caption or transcript is weak, the retriever might never even see the right artifact. This approach still struggles when the important signal is mainly visual or something that's not easily represented by a textual description.
Yes, if we want the system to truly search across text and images and not just use text as a proxy, we need something more.
And that is where our third approach comes in, which we are going to call full multimodal RAG.
I'm sensing a bit of a theme with these names.
You're correct.
So what's different this time?
Well, in full multimodal RAG, we don't just have text embeddings. We use a multimodal embedding stack, which has encoders for text, images, audio, and so forth. And all these encoders have been trained or aligned so they map into a shared vector space.
Yeah, this is pretty cool. So we've got some text documents here, and we can use this shared space. We've got some image files. They use the same. And then maybe we've got some, let's say, some audio. This can all go in here through this stack. And each one, as it goes through the stack, becomes a vector in the same space. And that gets stored as before in one big vector database.
Correct. Yeah. So that vector database is now truly cross-modal. Some vectors represent text chunks, some represent diagrams, and some represent frames from a demo video.
Then when a user asks, what's our latest VPN policy as the input prompt here, well, that then goes to the retriever, which then uses the same multimodal embedding model.
And that single query vector can directly retrieve policy paragraphs, network diagrams, maybe even a key video frame from a training video, all by similarity search in that shared space. So we're no longer bottlenecked by how good the captions or transcripts are.
Which is great, but the trade-off is cost and complexity. You need strong multimodal encoders, more compute, and sometimes some pretty clever summarization so you don't kind of blow up this context window here. But in return, you get the richest grounding. The system can search and reason across text, across images, and other modalities in a much more natural way. So that's full multimodal RAG. So to recap, Textify everything RAG converts all modalities to text.
And hybrid multimodal RAG retrieves over text, but lets a multimodal LLM see the originals.
Yeah, and then full multimodal RAG, this guy here, that makes both retrieval and generation fully multimodal.